Hello everyone, myself Harismita. Today I'll be explaining about Kruskals algorithm. Introduction to Kruskals algorithm. Kruskals algorithm is a popular method for finding the minimum spanning tree of a connected weighted graph. It was developed by Joseph Kruskal in 1956 and is widely used in network design. This algorithm operates by sorting edges and connecting vertices without forming circles. Key concepts. A minimum spanning tree connects all vertices in a graph with the least total edge weight. The algorithm works with undirected graphs where edges have weights assigned to them. It is essential to ensure that the graph is connected, otherwise a minimum spanning tree cannot exist. Step-by-step process. The first step is to sort all the edges in the graph by their weight in ascending order. Then the algorithm iteratively adds edges to the minimum spanning tree from the sorted list, provided they do not form a circle. This process continues until the minimum spanning tree includes all vertices or until there are no more edges to consider. Sort edges. Arrange all edges in the graph in ascending order based on their weights. Initialize disjoint sets. Create a disjoint set data structure to track the connected components in the graph. Initially, each vertex belongs to its own individual set. Iterate through sorted edges. Process each edge in the sorted list, starting with the smallest weight. For each edge UV with weight W, check for cycles and add edge to the minimum spanning tree and merge the sets. Repeat until minimum spanning tree is complete. Continue iterating through the sorted edges until the minimum spanning tree contains v-1 edges, where v is the number of vertices in the graph. Disjoint set data structure. The union find data structure allows efficient tracking of connected components and merging them. Find determines the set or a root that a given vertex belongs to. Union merges two sets, effectively combining their corresponding trees. Data structures used. Kruskals algorithm typically employs a disjoint set data structure to manage and track connected components. The union find structure allows efficient checking for cycles when adding edges. This helps in maintaining the connected components and supports two primary operations, union and find. Cycle detection. To prevent cycles, the algorithm checks if the endpoints of an edge belong to the same set in the disjoint set structure. If they belong to different sets, the edge can be added to the minimum spanning tree. If they are in the same set, adding the edge would create a cycle and it is discarded. Complexity analysis. The time complexity of Kruskals algorithm is primarily determined by the sorting of edges, which is O. The union find operations can be optimized to nearly constant time with path compression and union by rank. Overall, the algorithm is efficient for sparse graphs with fewer edges compared to vertices. Example walkthrough. Consider a graph with vertices A, B, C and edges with weights connecting them. By sorting the edges and applying Kruskals algorithm, we can visualize how edges are added step by step. Ultimately, the edges that form the minimum spanning tree will yield the minimum total weight connecting all vertices. Applications of Kruskals algorithm. Kruskals algorithm is used in network design to minimize the cost of connecting components. It helps in clustering applications where a minimum spanning tree can reveal natural groupings. The algorithm is also utilized in geographic information systems for optimizing routes. Comparison with Prim's algorithm. Both Kruskals and Prim's algorithms can find the minimum spanning tree, but they use different approaches. Prim's algorithm grows the minimum spanning tree from a starting vertex, while Kruskals builds it from sorted edges. The choice between them depends on the graph's density and the specific use case. Conclusion. Kruskals algorithm is a fundamental approach for solving the minimum spanning tree problem in graphs. Its efficiency and simplicity make it a valuable tool in various fields, including computer science and operations research. Understanding this algorithm enhances one's grasp of graph theory and its practical applications. Thank you for watching the video till the end, and don't forget to like the video.